for lesson 3.3. It's about graphing linear equations. And I would highly prefer that you get them into slope-intercept form. You do that by either solving for y or having it written as f of x equals some value of x plus constant. If you'll get it in that form, the coefficient of x will be your slope, and the constant will give you your y-intercept, which is a point you can start from. We have to start from a point, and then we'll move from there according to the slope. So I'll start with number 2. It says f of x is equal to 2x. The y-intercept is 0. The slope is 2. So I'm going to start at 0 on the y-axis. That's going to be my point up again from. And since my slope is 2, that means every time I move over 1, it's going to go up 2. So if I go over another, it goes up another 2 for a total of 4. If I go over another one, you get the idea. Okay, then all you have to do is just draw a straight line through the points. And you see how nice and straight my line turned out. But anyway, looks pretty good. And that's how you graph a line. Pretty simple. The only time it turns out that it's not real simple is if it's not in slope-intercept form. But that's fine. We can work with that. Number 4, f of x is equal to 2x plus 6. The y-intercept is 6. I'm going to, 1, 2, 3, 4, 5. That's what I was afraid of. 6. The slope is 2. So that means I'm going to go up 2 as I go over 1. Now I don't want to keep going higher because I'm on my graph, but I can back up. And if I back up instead of going up 2, of course I'd have to go down 2. That way I can preserve that moving up as I move to the right. And then just draw your line. But notice y-intercept is 6, and it moves 2 every time the input changes, being the x changes. Number 6 appears a little bit different, just because it has a fraction here, and you can't see what the y-intercept is, so it's going to be 0 because it's the same thing as plus 0 right here. Y-intercept is 0. And the slope is 1/3, meaning that every time I make a step over, it's going up 1/3. Well, going up 1/3 is kind of hard to visualize. Well, it's just there's no grid point, so it's hard to get it on there. So what we can do is we can go up the top number and over the bottom, because slope is rise over run. Rise, run. Up 1 over 3. And there's the graph. Notice this one's not as steep as a lot of the others, and that's because its slope was just a fraction. It was less than 1. But it was still greater than 0, and so that's why it's a positive slope. On number 8, it's another one of them with a fraction. This one, you can actually see the y-intercept. The y-intercept is -2, so I'm going to start from -2. Then this slope right here of 1/3 means that every time I take a move over 1, I need to go up 1/3. Once again, that's hard to see, so I'll go up 1 over 3, because slope is rise over run, up 1 over 3. You'll notice they're still in line, which they should be. And that's it. On 9 through 12, they want you to match it with the graphs above. I'm doing number 10 and number 12. So on number 10, the y-intercept is b. It's -2. And the slope is 5. So every time I move over 1, it's going up 5. That's a pretty steep slope. I'm going to draw my line. And that one to me looks like C. Whoops. You can see on number 12 that they give us the same slope, but a different y-intercept. So if both of these were on the graph at the same time, they'd be parallel, because they have the same slope, but just start at different places. Alright, I'm going to start at 3. The slope is 5, so every time I move over, I've got to go up 5. 1, 2, 3, 4, 5. I may have spaced that a little bit too much. So it's a steep slope, just like that other one we just did. But starting up at 3 instead down at -3. And this one to me looks like B, because it hits up here and it has that same slope of 5. Okay, starting on number 13, they ask that we graph using the x and y intercepts. But the only time it's really reasonable to do that is if the equation is not solved for y and in slope-intercept form already. And it's really preferential if you are in a standard form, where it's something x, something y, and the constant is on the other side without fractions for your coefficients. So to find the x-intercept, what I do is I let y equal 0, because if I was hitting the x-axis, my y value would be 0. And that would be x equals -4. So my x-intercept is -4. 1, 2, 3, 4. To do the y-intercept, I do the exact same thing. I will say, I'm going to change colors here. X has to be 0 on the y-axis, because that's when x is 0. So 0 minus y equals -4. That would be -y equals -4. And we end up finding that y equals +4. 1, 2, 3, 4. You'll notice this is a lot more writing than when we do slope-intercept form. And probably if I had just took this equation and solved for y and got it in slope-intercept form, it would have probably been even easier than what we're doing here. But anyway, that's the process to be able to do a graph using x-intercept and y-intercept. Okay, now I have number 16, same directions. So to find the x-intercept, we let y be 0. Then I solve for x. Also, we have letters that we use to represent the x-intercept and y-intercept. The x-intercept, you can use A, so it's at 0. And now I'm going to do the y-intercept. Change colors here. To do the y-intercept, I'll let x be 0. 2 times 0 is 0. So if y is 0, my y-intercept is 0. Makes it kind of difficult to do a graph with only one point, isn't it? If you rewrote this as slope-intercept form, I'm just going to do a symmetric property of equality and put the y on this side and the 2x on this side. I'm just switching everything. It's kind of like if 2 plus 3 equals 5, then 5 equals 2 plus 3. The slope is 2. So when I move over, I need to go up 2. So using the intercepts was definitely not the best way to do this problem. But we played their silly game. Not my best looking graph I've ever done, but there.